Have you ever really thought about what happens in that tiny, tiny sliver of time after you hit send on a message? It feels completely instant, right? But underneath that surface, there's this incredibly complex and honestly elegant set of rules that makes it all work. Today, we are pulling back the curtain on that 7-layer secret language of the internet, the OSI model. Let's dive in.
So just picture it. You're in an app, you type out a quick message, hit send, and poof, it just magically appears on your friend's screen, maybe thousands of miles away. But how? I mean, how does the data from your phone navigate this insane global maze of cables and routers and servers to get from point A to point B?
And that right there is the fundamental problem network engineers had to solve. You've got iPhones trying to talk to Androids, Windows PCs sending files to MacBooks. They're all built differently, with totally different hardware and software. You know, without a common rulebook, it would just be pure chaos. They needed a universal language, a blueprint everyone could agree on. And that blueprint is the OSI model. It was created to be that standard, that reference guide that anyone, any manufacturer could follow. Now think of it less like a specific program on your computer and more like a super detailed 7-step recipe for sending digital information. And yeah, the internet today actually uses a slightly different model in practice, but the OSI model is still the master key to understanding how it all works. To make this whole journey make sense, we're going to use an analogy. Let's imagine you're sending a letter, but it's a digital one. We're going to follow your message every step of the way, as it gets written, packaged up, addressed, and mailed out by the internet's own ridiculously efficient postal service. So our journey starts at the very top of the model, right where you, the user, are actually creating the data. These first 3 layers are all about getting your message written down, translated correctly, and basically ready for a conversation. We start at layer 7, the application layer. This is the only one you actually see and interact with. It's your web browser using HTTP, your email program using SMTP, or in our example, an app like WhatsApp. This is literally where you type out the letter you want to send. Okay, so once you've written your message, it gets handed down to layer 6, the presentation layer. This is the universal translator. It takes the data from your specific app and formats it into a standard, generic way that any other system can understand. This is also where really crucial stuff happens, like encryption, scrambling your data so no one can snoop on it, and compression, which makes the file smaller so it sends way faster. Then we hit layer 5, the session layer. You can think of this layer as the conversation manager. Its job is to open a direct communication line between your device and the receiver's device, make sure that connection stays open and stable while you're talking, and then close it down neatly when the conversation is finished. It just keeps the whole back and forth orderly. And right here is where a super important concept kicks in. As our data moves down through these layers, a process called encapsulation begins. Each layer adds its own little packet of instructions, called a header, to the data. It's kind of like taking your letter and putting it into the first of many envelopes, each one with specific instruction for the next step of the journey. Okay, so the message is written, it's translated, it's ready. Now, we've got to address it properly so it doesn't get lost in the mail. These next 3 layers are all about logistics, making sure our little packet of data knows exactly where it's going.
Layer 4 is the transport layer, our digital delivery manager. Now, if your message is really big, this layer chops it up into smaller, numbered chunks called segments. It also adds something called a port number. Think of it this way. If your device's IP address is a huge office building, the port number is the specific mail slot for the right app inside. It makes sure your message goes to WhatsApp and not, say, your web browser. This layer also handles things like error checking. So you know when your video is buffering, that's often layer 4 at work, managing that data stream to keep things running smoothly.
Next up is layer 3, the network layer. And this is where the magic of global communication really kicks in. This layer adds the logical address, the famous IP address of both the sender and the receiver. This is the full global street address that routers all over the world use to pass your packet along, hop by hop, toward its final destination. And finally, for addressing, we have layer 2, the data link layer. Now listen, if the IP address is the final destination city and street, the MAC address that gets added here is just for the very next stop on the journey. It's the physical address of, say, your home router. It's like handing the letter to your local mail carrier, who only needs to get it to the neighborhood post office. That MAC address is going to change at every single hop along the way. And what we end up with is the full picture of encapsulation. Our original little message is now nested deep inside all these layers of instructions, kind of like a Russian nesting doll. Each layer has added its crucial piece of the address, for transport, for routing, and for local delivery. The packet is now fully addressed and ready to ship out. The letter is packaged, sealed, and addressed. There's only one thing left to do now: put it on the mail truck. It's time to get physical. This is layer 1, the physical layer. All of that carefully structured data, all those headers and segments, they now get converted into raw signals, just ones and zeros. These are the electrical pulses zipping through copper cables, the tiny flashes of light in fiber optic lines, or the radio waves floating through the air for your Wi-Fi. This layer has no idea what a message is. It's just pure, raw transmission.
I know. That is a lot to remember, right? Well, lucky for us, network engineers have a handy little mnemonic to keep the 7 layers straight, starting from the top. It's all people should try new dishes, please. That stands for application, presentation, session, transport, network, data link, and physical. Pretty clever.
Okay, so our message has made it. It has crossed the country or maybe even the world as a stream of raw bits. But now, the receiver's device has to do the exact opposite of everything we just did. It's got to unpack the message.
And this reverse process is called decapsulation. It's really cool. The receiving device catches all those bits and starts moving them up the stack. At each layer, it reads the header that was meant for it, does its job, and then just strips that header away, passing the cleaner package upwards. So layer 2 reads the MAC address and strips it, layer 3 reads the IP address and strips it, layer 4 puts all the segments back together in order, and so on, until the original clean data is delivered right to the correct application.
Now, I know what you might be thinking. This is a great theory, but is this what my computer actually uses every day? And you know what? That is a fantastic question, because the reality of the modern internet is just a little bit different. Here's the deal. The internet doesn't strictly run on the 7-layer OSI model. It actually runs on a more practical 4-layer model called TCP/IP. And the key difference is this. The OSI model is the conceptual blueprint. It's the theory that explains how things should work. TCP/IP, on the other hand, is the actual implementation. It's the collection of real protocols that defines how data actually moves around online.
So, why did we just spend all this time learning 7 layers? Because the OSI model is still the ultimate tool for understanding and for troubleshooting networks. I mean, when something goes wrong with a connection, engineers will literally ask each other, hey, is it a layer 1 problem? Meaning, is the cable unplugged? Or is it a layer 3 problem? Meaning there's an IP address issue. Ever had tech support ask you to check if your router is plugged in? They're starting their troubleshooting at layer 1. It gives everyone a common language to diagnose problems logically, from the physical wire all the way up to the application.
So, the next time you tap send, just take a second. Try to picture that little message being wrapped, addressed, converted into flashes of light or electricity, shot across the world, and then perfectly unwrapped in a fraction of a second. It's this invisible, 7-layer dance that happens billions of times a day, all thanks to this incredible, elegant blueprint.